Hello everyone, welcome to the final episode of our series where we're recreating the classic game of columns using SpriteKit. Today I want to implement the final feature of the game, and that is showing the next 3 gems that the player will get after making a match. So let's start in our board test and creating a new section for next gems, and create a first test that says a board has 3 next gems. So we'll create a board, and then we'll assert that the board next gems count will be 3. Now the next gem doesn't exist yet, but we can quickly add it. And let's do an empty array first. So now the product again compiles. Okay, but this is the test fails because we only get an empty array back and not 3, but this is easily solved by making sure that, for instance, we always get a green and now this test should pass. Okay. However, always getting green ones isn't very useful. So I'll say that the next gems are never 3 of the same type. So I'll create a board. I'll say next gem is for the next gems, and then I'll say I'll assert that next gems 0 is equal to next gems 1, and next gems 1 is equal to next gems 2, so this way they are all the same. This one is false. So let's run the test. And now this test fails. And also this one fails. And the reasons are linked to each other. So this test is flaky because it assumes that some new gems are being created, and sometimes 3 of the same kind are created and then they immediately disappear. So then in that case this test fails. However, if you run it again, typically it tends to work, but it doesn't always work, and that makes it flaky. And this one fails because we're hard coding the to only send back green gems. So let's add a bit more smartness. So we could say we'll just say, okay, I'll insert also a red gem and, for instance, a blue gem. So now this test passes, but the other one still fails. So I think what would be probably be a better idea is to add some logic in creating the new gems. So we have a spawn new gems function. Let's create a function called random gems that returns an array of gems. And we'll create some next gems. Three random gems. But if the next gems 0 is equal to next gems 1 and next gems 1 is equal to next gems 2. We'll just iterate, just do a couple of attempts by changing one of the next gems to a different value. Nope, that's not remove random element, it's just a random element, and return the next gems. So if we now use this function, I'm not sure we can use it immediately here, because yeah, this one that's because this one gets initialized before everything is initialized, and then I can't call a member function yet. We'll pick it up in a bit. So we have a function to create random gems. Let's go and use it in a bit. So this test should of course pass. Let's create the final test, and that's that when spawning new gems, the next gems are used. Create a board, then we'll say updated board is board.update. Then we'll assert that the updated board's gems at vector 313 are equal to the first board's next gems, the first one, and the second one, and the third one. So we're comparing the actually spawned gems in updated board to the next gems in board. Now this test should fail, but it can pass because gems are spawned at random, so there's of course a chance that they are happen to be exactly the same, but they don't. Okay, so let's start using the next gems function. So let's go to where we have our spawn new gems. Instead of here choosing random elements, what we'll do is we'll just say this will be next gems 0, next gems 1, and next gems 2. And we'll say next gems equals random gems, and that's where we can use our function. Now let's test. Let's run the test, and now the test passes. So now we have next gems. Let's use them in our UI. So let's go to our content view, and first thing I'm going to do is I'm going to get rid of these debug options because I don't think we need them anymore. So let's see, we have here our score and our level. I'm going to put all this stuff into an H tag. And then we have a stack that shows the score and the level. I'll add a bit of a spacer, and then we create another stack that also starts with a spacer, but this one says next. And here I'll just create an image of scene board next gems 2, raw value 1 and 0. So I think this is enough to actually show the next gems on the screen. Let's see what happens when we build and run. Okay, so we have a falling stack, and the next stack has red, red, yellow. And indeed, red, red, yellow, red, green, and blue, red, green, and blue. So it seems that this functionality is now working. Cool. Well, that's actually what I initially planned to implement. But I decided that the game is missing something, and I think well, it's probably missing a lot of things, but what I miss most is sound. So as a sort of bonus, I want to implement so I have some sound effects. Let's drag them into the project. Let's copy them here, and let's quickly add them into the game. So let's go to our game scene, and this is fortunately quite easy. So we have our removed gems. Here we can say let SFX is an SK audio node with a file name for remove gem.gem.wav. We have auto loop played equals false. Otherwise it tries and loop the sound effects, and that doesn't make sense because the sound effects are really one-offs. Then we run a sequence of actions, and the first one is to play the sound effect. Then we wait for a bit, let's say half a second, and then we remove it from the parent, and then we say root node add child sound effects. Let's see what happens. Let's build and run. Okay, so we have some falling here. We can't make a match immediately. Well, we should be able to in a bit. Let's something like this. Oh, we can make a match with the pink one. And now the game freezes for a bit, and oh, I'm not sure if you can hear the audio currently. That's a good point. It's probably going through the microphone and not from the game itself, so I hope you can hear it. And I have different sound effects for the various gems, so they all sound slightly different, although they all sound a bit like 8-bit coin collection things. Okay. But the first time we wanted to play something, we had this pause in the game, and I'm not completely sure why that happens. That tends to happen in every sprite game game I work on. So perhaps I don't know the exact reason. I do have a workaround, and that's a trick by having first playing just something, because after the first one nothing happens anymore. So what I do is when I start up the game, I play a sound effect called silent, and this sound effect is completely silent. It doesn't have any audio, but it's just enough to sort of initialize the audio system, I guess, something like that. So the silent effect, we should run a sequence, and we can start by playing the sound effect, and then we remove it from the parent, and we add it to the root node, and that should be enough. So let's see if the issue still persists. So we have some falling gems. We can make a match on the next one. Okay, so let it fall. And now there's no more delay in when making the first sound effect. Cool. Well, that's my simple implementation of columns using SpriteKit. If you made it until the end of the series, thank you very much. I don't know yet what the next one will be, but we'll see. For now, thanks for watching and have a great day.